So I'm going to explore a basic proof for the Atwood machine formula. So there are two mass blocks M1 and M2. They are connected by a string that has tension ET all over the string. So the first assumption while using the formula, we have to take care of that M1 is greater than M2. So the block will accelerate towards M1 and acceleration will be downwards. Since acceleration is downwards, we can use Newton's law to create an equation. M1g minus t is equal to M1a. Since it is M1g minus t mass into acceleration, I am using Newton's law. Summation of force is equal to summation of MIAI. I hope it is correct and it is understood. So M1g minus t is equal to M1a. Second, I will use Newton's equations in this case. Since the acceleration is upward, so the equation will be t minus M2g is equal to M2a. So I have here two equations. So I will add them from both sides. Adding them on the left sides, I will get a M1 plus M2. Since I am getting M1a plus M2a, so a will be common. So in brackets, I will get M1 plus M2. Clearly I can see the signs are opposite, so the tension will get cancelled out, and the g is common also on the both sides, so I'll take g common, M1, and there is a negative sign, M1 minus M2. So the acceleration value of acceleration that I got is g M1 minus M2 divided by M1 plus M2. So to get the formula of the tension for the Atwood machine, that is also known as Atwood formula, I can put the value of acceleration in any of the following equations. So I'll put the value of acceleration in this equation, since t is equal to M2a, and I will transpose this M2g towards the right side. Okay, I hope it is clear. M2. As for a, I'll put this value instead of a. I'll put g M1 minus M2 divided by M1 plus M2. I hope this is clear till here, plus M2g. So this term and this term M2g is multiplied with the whole acceleration, and this the value is put up here. Okay. So M2g and M2g both, so I can take it as common. M2g is taken up as common. Since M2g is taken common, so the things that will be left inside will be g M1 minus M2, M1 plus M2. Since M2g is taken common, so here will be 1. Now it is clear, the formula is clear to us. We can take LCM, M1 plus M2. The formula is surprising to us. We can multiply them. So we also had taken g common, so I'll remove g here. So I'll cross multiply M1 minus M2 plus M1 plus M2. This is just basic maths. We have taken LCM. M1 and M2 will get M2 and M2 will get cancelled out, and these two terms will get added up since the sign are same. So this will be M2g. Since the sign is same, M1 plus M1 will be 2M1, and in the denominator it is M1 plus M2. So the tension will be equal to twice M1 M2 G M1 plus M2. So this is the Atwood formula, the tension in our Atwood machine, and this is the acceleration in the Atwood machine. I will explain it once more time. So we calculated these two equations using Newton's law and added the equations, so we got the value of acceleration. Then we put the value of acceleration in any of the equations. I used equation 2. I transposed M2g to the right side, and we got this expression. So instead of a, I put this value that I just derived. So and M2, since this was in multiplication here, M2g, I took it as common. So M1 minus M2, M1 plus M2 plus 1. Then I did a basic LCM here, M1 plus M2. So and then cross multiplied this with this, and M1 and M1, they same, they have like signs, so they got added as twice M1, and M2 and M2 they have different signs, so they got cancelled out, and this is the basic maths to get the value of tension. I hope it's clear. Thank you.